Hello. I have introduced two types of oil-water separation technologies. The first was filtering that uses nanofiber filters to filter out water and recover oil. The second was draining, which uses sensors to control valve opening and closing to discharge water and oil. This time, I will show a more practical version of the draining method. And it will be easier to understand this video if you watch the last video first. This is a mixed liquid separator that I invented. Let's look at the components. First, the main body, a simple container that can hold liquid. I made it small, 3.5-liter capacity for convenience in the experiment. In reality, considering the inflow speed of the oil mixture, the length from the inlet to the outlet should be longer. But this container is 20 centimeters long. Second, the drain valves for water and oil, which are connected to the controller to open and close. As an important part, the size of the valve outlet can determine the amount of emissions. And the valve in the picture has a 10 millimeters orifice, so its emission is very small. Third, the sensor module. This part is different from the last time. Last time, it was a combined type that was long. But this time, it is a separate type that is divided into top and bottom. The separate type does not matter if the two outlets are far apart. In addition, even if the two outlets are separated left and right, or even if they are installed on different sides, they can be installed next to the outlets. So they can be used conveniently in large tanks. Inside the sensor module there is a floater like this. The floating body is a specific gravity body that naturally floats on water and sinks in oil. And it moves up and down while maintaining a vertical state rather than horizontal. And a sensor that detects this floating body is installed inside the module. Fourth, the controller. It receives data from sensor modules installed in the tank. Then it opens or closes the valves by connecting electricity to them. Now let's look at the test video. As I mentioned in the previous video, the water tank is minimized because the test is based on the mixture already being separated into upper and lower layers. And the separate sensor modules were installed inside. And the valve always stays closed when the power is off. Currently the oil and water are almost half full, enough to submerge each valve. In this test, please take a good look at the valve operation according to the movement of the mixture interface. I'll power it up. Oil and water are being discharged through each valve. As the oil surface moves below the oil outlet, the oil discharge stops. As the oil approaches the water outlet, the water drain also stops. At this height, the water discharge has stopped. Now we'll supply water to raise the water-oil interface. At this height, the water starts to drain again. This difference between the stop height and start height of the water discharge is the valve operation gap. This prevents frequent valve opening and closing due to change of interface. Let's add more water to raise the liquid interface. When the interface gets close to the oil outlet closes. oil discharge stops here. Please take a good look at this height. However, the mixed liquid interface continues to rise. And then comes down again. As it moves down from the oil outlet. Finally, at this height, the oil outlet opens again and the oil is discharged. The stopping height and starting height of the oil discharge are also different. This is the same concept as the valve operating gap. Now the water goes up above the oil outlet altogether. However, when the water approaches the oil outlet valve is already closed. So the water does not drain into the oil outlet. If you have seen this far, you have seen the entire operating principle of this oil-water separator. When the interface approaches the water outlet or the oil outlet, each sensor detects it in advance and the controller closes each outlet valve. And when the interface is far enough away from each outlet, the sensor again detects it and the controller opens each outlet valve. This way, the oil and water can be separated and recovered as pure water and oil without any mixing. If applied to a real situation, an oil mixture would flow into the inlet of a large tank and around the outlet on the other side of the inlet. The oil and water layers would be separated naturally. The water spewed out through the water outlet valve and pump is finally discharged outside the ship, while the pure oil discharged through the oil valve and pump would be collected and stored separately. Finally, a more ambitious application would be to build the spill oil recovery vessel with this technology. If the spilled oil is blocked by the oil fence and directed to flow into this vessel together with seawater, the vessel itself becomes an oil-water separator, allowing the seawater to be immediately discharged into the sea as in the experiment, and the oil to be filled into oil bags, sealed, and sent back to sea. This focuses on separation itself. Because with thousands or tens of thousands of tons of spilled oil, it's imperative to get it into a manageable state first. Therefore, the oil spill recovery vessel only needs to separate the oil for 24 hours straight and release the oil bag into the sea. The oil bags would then be picked up by another vessel, transferred to a vessel that stores the oil in the vicinity, and the emptied oil bags would be delivered to the spill recovery vessel for immediate reuse. If this is actually done, this would be an ideal spill recovery process that would quickly recover a lot of oil intact. Of course, it would require a lot of experimentation. I was so motivated that my thoughts went far away. Oil is essential to our lives, but we must always be careful to handle and use it so that it does not harm us. Thank you for watching this.